Okay, so I'm going to be talking about building a custom React renderer. So I'm at a Node.js meetup talking about React, which is a front-end library. So like, what business does React have at a Node meetup? And that's because I'm going to demonstrate how React can be used for more than just writing front-end code. And okay, let me introduce myself. Oh, by the way, if you're interested, you can go to this URL and follow along, or you can just watch the PowerPoint. But, oh, it's too loud.
You're good.
Cool. Okay, sorry, this is not a PowerPoint. This is actually built in React. So anyways, okay, so yeah, let me introduce myself. I'm Jam Risser. I'm a software architect at a company in town called Silicon Hills, LLC. I write Node and React, and Silicon Hills, we do Node and React for we do custom Node and React development and support for Node and React. And that's my Twitter handle and my GitHub repo. So, okay, so yeah, I thought this was a Node.js meetup. Why React? Why React in Node? So I really appreciated the previous talk because he was talking about loose coupling and highly cohesive code, and React just kind of naturally has a lot of those things, the way it was architected. React is highly composable, so you can take React components and kind of shove them, mix them all up together, and they're very, very loosely coupled, right? And then also React, the way you write React code, you write it in a very imperative way. So you just tell it what you want. You don't really have to tell it how to get there. You want a button to show up, you just tell it, hey, I want a button. In my case, I'm going to be building a renderer that renders code. So I just tell it, hey, I want this code to be rendered, and it goes and renders it. So yeah, let's talk about React a bit. So here I have a little diagram. I don't know if you guys can see it very well, but this is basically a diagram of how React kind of works. Oh, it didn't move on to the next?
No. Just now. So if you notice that the time difference, that's probably possible.
Okay, but everyone can see the diagram?
Yes.
Okay. So yeah, this is basically how React abstracts the rendering. So you have a virtual DOM where you basically create a tree structure of what you're trying to render. And you create this tree structure using React components. So that's these purple circles. So you might have a form that's going to have a button and an input inside of it. And what this React component does is it's made of, once you really get down to it, it's a bunch of abstraction that eventually ends up being what are called React elements. And React elements they're kind of like a React component, but they're not the same thing as a React component. And you use them like a React component. But the thing that makes them different is they have a piece of data on it called the node. And the node is basically what it's binding to. So this diagram shows how React DOM works, how React would bind to the DOM. So you have these intrinsic elements, right? When you're typing out your React on the front end, you use these lowercase components. These lowercase components are what directly binds to the real DOM. That's these little dotted lines here. That's the real DOM. And the way it binds to it is basically by manipulating the node. And the node is different depending on what React renderer you're building. So in the case of React DOM, the node is the DOM, is the real DOM. In the case of React Native, the node would basically be the direct bindings to the mobile app rendering. And in my case, since we're writing a renderer that renders code, the node is going to be basically a Babel abstract syntax tree. So let me tell a little story of how I came to build React AST, which is the React renderer for rendering code. So I've been working on this project for a while called React GTK, which is basically a React renderer for rendering to native desktop. So it's different than rendering React to Electron, because Electron just uses React DOM as a renderer. So this is, so you can, React GTK basically binds to the native GTK library, which is a C library. But this is a very intense project because this GTK is basically one of the most popular libraries for rendering Linux graphics, and it's been ported over to all other operating systems. GIMP was written in GTK. The Ubuntu desktop environment's written in GTK. So there's a lot of Linux stuff that's uses GTK, as well as software that's been ported. So it's powerful, but it's such an old library, in a good way old, as in it's a very large library, very large ecosystem. So I found that writing it was taking way too much time because there's so much code. So, and when I say so much code, you'll understand in a bit. So, the problem with lots of code is not just that it's a lot of work, especially for a well-maintained library like this. You can't even keep up with the development. So you get everything working, and the next day, everything's changed. So I needed to basically come up with a way to automatically create this library based on the C library. So in order to do that, I was building this in TypeScript, and I needed to, as just kind of a foundational dependency, I needed a bunch of TypeScript bindings to this library. And these are basically the TypeScript bindings that I had to write. And just to give you an idea of how much code this is just the TypeScript bindings. This is not React GTK. And TypeScript bindings don't really have a lot of code, in the sense that, like, the actual implementation is not here. This is just TypeScript bindings. So these libraries combined is 40,000 lines of code. So it's very, very large, and that's just the TypeScript bindings. So in order to build this 40,000 lines of code, I did not really write 40,000 lines of code. Instead, I wrote another library that goes through the C code. Actually, not really the C code. It goes through the bindings to the C code, which is these huge XML files, and generates TypeScript from that. And this is basically the approach that I'll use for building the React renderer. But I ran into a very big problem, and that is it started becoming very, very, very unmaintainable. Because this code is, I'm just directly manipulating the Babel AST, and don't even try to understand this code. I wrote it, and I don't even understand it. So it's very declarative. It's not very, it's very coupled, right? It's all those bad things. So I needed a better way to render out this code that was loosely coupled. And so that's kind of where you come to React AST, which is basically a way where I can write these React components that then generate code. And what's really nice about this is it's so composable that I can just I can write a React component. I can write code to generate a functional React component, and then I can write code to generate a class-based React component, and then I can write code to put in the body of that React component, and I can just change which, oh, am I going to use it as a functional component or a or a class-based component? I can easily switch and mix these things up. I could write a React AST component that makes Express middleware, and then I could take my React component and shove it into the Express middleware. That's how composable it is. So that's what I'm going to demonstrate here. So another repo that I made specifically for this workshop is create React renderer, which is basically what I'm going to go through. I'm sorry, what? Bump up the size. Yes, there we go. So yeah, so let me go back to, that's the kind of the context around this. So let's build it. Okay, so some definitions. Let's actually, who here has worked with React? Okay, so we have a good general understanding of React, so that's good. So I'm just going to go over some definitions and a disclaimer, these are not official definitions. These are definitions just to give us a common understanding of what I'm talking about. And they're also coming, these definitions are from the perspective of building a renderer, not from the perspective of using React, okay? So the virtual DOM is a tree structure that represents the current rendered state of React. That's basically these dark lines here. It's the tree structure of your React code. Okay, then we have this thing called reconciliation. So reconciliation is the process of determining which parts of your virtual DOM need to be changed by diffing the current virtual DOM tree with the new virtual DOM tree. And based on that definition of reconciliation, there's this thing called a reconciler, which is basically the React bindings, or the bindings to the React reconciliation lifecycle methods, which is really nice because I don't have to write the reconciler. React has already written it. Okay, fiber, we won't really get too much into fibers, but it does come up once or twice in the talk. Fiber is a virtual stack frame of work for the React reconciler. So you can think of the fiber as basically the underlying core library that the React reconciler is built on top of. A node, not Node.js, is the interface of the renderer that the React renderer is binding to. So the node is a really important concept for this because it's basically where your API, it's basically the APIs that of the thing you're specifically trying to render. So in this case, it's this blue box, right? It's the real DOM is what ends up being used as the node in the case of React DOM. Okay, and basically every single React renderer has a very different node because each React renderer is rendering to something different. Okay, yeah, the root node is the node at the very top of the React virtual DOM tree. Yep. Okay. Element. So I mentioned this earlier. An element is a React, it's not technically a React component, but it can be used like a component. But it's basically a React component that is directly bound to the reconciliation lifecycle methods. You can think of it as a React component that has access to the node. That's what you can think of it as. The base element is the element that you use to create all your future elements from. That way we can share a lot of the code across our elements. And then we come to a React component, which you all probably already know. And that's basically an encapsulation, and this is a definition from the perspective of the renderer, but it's an encapsulation of all other components and or elements. And the root element is the element used at the top of the React virtual DOM tree. So I mentioned the root node earlier. So the root element is going to have the root node attached to it, of course. Okay, let's get into building this. So phase A, the first thing to do when building a custom React renderer is to set up your reconciler. So I already have the code here for phase A. So if we go into this README file, yeah, the first thing we need to do is create this reconciler, that's the API bindings to React for handling our reconciliation. So we use this library called React Reconciler, which was built by Facebook. And it basically has a bunch of lifecycle methods in it. So create instance, append initial child, finalize initial children, all these weird methods. But they're lifecycle methods. But they're not the same thing as component lifecycle methods, although they're related to the component lifecycle. These are rendering lifecycle methods, or it's the lifecycle of your reconciler. And so you just go in here and fill in the details of what you want to happen during when these functions get triggered. So what I did is I just logged the name of this event, basically. Okay, and I'm not really doing anything other than that. This is all pretty much boilerplate code. Okay, then you want to create your base element. So your base element is the element that all future elements are going to be created from. So the base element also has similar lifecycle looking methods. And these lifecycle methods will get triggered from the reconciler. So the reconciler, when the reconciler's lifecycle methods get called, they're going to call into your elements lifecycle methods. And right now, I've not filled any details in. It's just, again, just very boilerplate code. And then the last thing that you want to do is you want to create your render function. So if you've ever set up a React project, you'll have to call this render function. And in my little example here, I call the render function and I just pass in basically nothing into it. But in a maybe like a React web app, you'd pass in your root app node component. So it's a very similar concept. So this render function is basically when the rendering happens. And basically, the first thing you do is you create your root node. So here I'm creating the root node, and I'm actually just setting it to an object. So in this phase A, what I'm binding this renderer to is just to an object. So pretty much to nothing really that special. Not to Babel for generating ASTs, right? You don't want to start complex. You want to start really, really simple. Then we pass in this root node into our base element. So now we've created our root element. And then we basically create our root fiber. And you do that by passing in your root element. And so we're basically here, we're just initializing everything. And then last, you reconcile your virtual DOM, which is a very fancy way of saying you render your code, basically. And it uses this update container function that the React reconciler has. And so we basically pass into it, I'm passing in the JSX that is coming into the render function, and I'm passing into it the root fiber, and then I'm just not using anything else after it. Now this last step depends on what type of renderer you're making. So there's two types of renderers. There's basically side effect renderers and renderers that basically like a direct renderer. So a side effect renderer is what you would usually think of when you're thinking about rendering. The renderer is not going to return the rendered result. It's just going to have side effects on it. So for example, as your React is rendering, it's updating your DOM. It's not really, the render function isn't really returning anything useful to you. A direct renderer is basically, you have the render function return something to you, and that's it. That's the end of the render. So something unique with direct renderers is that there's you don't need to really worry about updates, because after the render function runs, that's it. Like, for example, generating code. I don't really need to keep the thread running and like, oh, what happens if I update or make changes? Like, you render your code, you're done. Like, it's done rendering. So that's what's happening here. I'm just returning the root node from the root element, and that's my rendered code. Or actually, would be an abstract syntax tree. But in here, it's actually just going to be this object, hello world. Because this little phase A renderer that I made is a renderer that just renders an object. So let's test it. Let's go into our phase A and let's run it. And you can see the rendering lifecycle methods getting triggered because I was logging them. So it ran get root host context, it ran prepare for commit, it ran reset after commit, and boom, here's our rendered stuff. One other thing about direct renderers is they're easier to make because you don't have to worry about updates. They're a lot easier to make. So, but they would never work for something like a user interface because you want the user to interact with the app. There's no interaction with a direct renderer, but you don't need to interact with rendered code. So, okay, cool. Phase A is done. Let's move on to phase B. Okay, phase B. So phase B, we're going to create some custom elements. So if you remember, elements are those basically React component-like things that have nodes attached to them. And what's neat about elements is we can actually start writing some JSX. So the first thing is to create your element constants. So this is going to look very different than creating a React component, okay? Because these elements are directly bound to your node. So we first create some element constants that we export. So here I'm creating two elements, actually three. One called hello, one called howdy, and one called wrapper. So we export the constants. And this is basically what React will use as your JSX. You'll use these as JSX. So you can actually, you'll be able to say hello in your JSX like this. And then we create intrinsic element types. This is only necessary if you're using TypeScript. So because the type of this hello, when we start using it like JSX, it's not going to be used like a string, even though it is a string. We still have to define its type somewhere. So that's these intrinsic elements types. So here here's like the props basically that these have. And so I'm just putting ref props on them, and wrapper is going to be able to have some children. Okay, and then the next thing that we do is we create the elements. So here's our elements. So if you remember, we had this base element. So I'm going to extend the base element with these elements. And if you look at the constructor of the base element, the first thing is the node, basically. So we start attaching the nodes to it. So for example, hello, the node that hello is going to have is going to be hello world. The node that howdy is going to have is howdy Texas. And the node that wrapper is going to have is cool beans. Okay, so yeah, so elements should extend the base class. Okay, then we have to just make one small change in our render. So if from the previous render, because we didn't have any elements, we just had the base element, I kind of had to make a base element, right? Here's the custom node that I added, but we don't need to do that with this because we already have some elements. So instead of, I was just able to reduce some code here. I just create the element. It's already gonna have a node inside of it, right? Wrapper is gonna have this cool beans node inside of it. And then everything else is still the same. So when I render this, it's gonna render the root node. And the root node, let me see if I did this right. Yeah, the root node is this cool beans. And oh, let me look at the example. So but if you look in the example, I'm passing in, oh yeah, I'm not passing in the wrapper yet, okay. So yeah, I'm passing in hello and howdy. So it's gonna render these two components, basically. So it should show us those nodes. Okay, so let's do it. Phase B. Okay, so, oh, I know what, yeah, sorry, that's what I was meant to do. So it doesn't look like, right, it rendered cool beans. It rendered wrapper. It did not render hello and howdy. Like that seems really weird. And that's because we never told it how to handle children or anything like that. We just passed it in our render function. We passed it wrapper, and wrapper doesn't know what to do when it has children. So it's just rendering out wrapper, the root node, and that's it. So that's actually expected behavior. So again, we're starting simple and then we'll get more complex. Okay, let's go on to phase C. Clear all these pages. Okay, phase C. All right, we're gonna bind some custom elements to the reconciler. And this is basically the step that's gonna allow us to start appending children to other nodes, React nodes. Okay, so basically there's some critical reconciler lifecycle methods we need to fill out. The first one is called create element, and the second one is called append child to container. So if we look in the reconciler, right now it was completely empty. We didn't tell it what to do through a reconciliation process. So create instance is going to create the element from whatever JSX it was specified. So it's going to go through each JSX element and then create the specific element. So it's very similar to where we create the root element, but instead of creating it from our render function, it's creating it from the JSX that we provide. And the other one that I gave it was basically telling it what to do when it gets children, when it has children inside of the JSX. And basically I call container.append child. And container is the element. The reason it's called container is because this could be a component or an element. But anyways, we say container.append child. That's going to call the append child method on the element. So with those two functions specified, we can now start, let me look at the example again. Yeah, we can now basically render these things inside of our wrapper. So let's look at the wrapper component. So the wrapper component has this append child method inside of it because this method will get called whenever a child is appended into the wrapper, whenever you give the wrapper children JSX components. And so here we just say how to manipulate the node when we've appended a child. So basically the node, I've renamed the node from, I forget what it was. It was cool beans. I changed it to be a greetings array. So whenever you provide children, it's going to just start pushing the children nodes into this greetings array. So basically what we should see when we render something like this is each of these nodes, each of their nodes should get appended into the root node's greetings array. And because if we look at something like this howdy component, there is no append child method. If I was to try and put children inside of howdy, it's not going to do anything because there's no append child method. So that would not do anything. But I can append children to the root node. All right, hopefully I didn't break anything. Okay, let's try it. Phase C. So we should see a greetings array with all the greetings rendered inside, and there you go. World, Texas, world, world. Hello, howdy, hello, hello. Yep. Okay, so that's phase C. Yeah, so actually phase D, I'll talk more about wrapper. So wrapper is just an element that I decided to make, right? It's not anything specific to, you don't have to make a wrapper. What you have to have is you have to create a root element. So in your render function, you have to create some root element that all future elements start appending children to. And I just called it wrapper. But as you'll see in phase D, I actually replace wrapper with a different root element because I'm building a renderer for rendering code. All we've been rendering is JavaScript objects. So I'm going to start switching things up to actually rendering code. The reason I did phase A, B, and C is because you should get the basic rendering concepts and also like make sure that your lifecycle methods and elements are being attached. You should get all that in place first before you start trying to put in your custom node. Because if this stuff isn't working, there's no point in trying to bind it to a GTK library or bind it to whatever you're rendering you're making. So phase D here is basically where we set up our node. So we're going to replace this object node that we've been doing with an actual node that's going to be useful to us. And here I say from this point forward, everything is very specific to the React AST renderer, but the basic concepts remain the same. So our steps here is to create a node type. This is if you're doing TypeScript. So you'll see here, I just had base node. It could just be anything, basically. Now I'm actually specifically saying this is what a base node is going to look like. And this is going to be different depending on what you're rendering to. So this here, this object is actually a Babel AST object. So start and end is like basically where the code, the line numbers of where the code starts and ends. And this is all just Babel stuff. But it doesn't really matter too much. But you need to define, if you're using TypeScript, you need to have the type set of what your node's going to look like. And then we replace the element that we were using with our actual, replace the element used for the root element. So our root element in phase A, B, and C was wrapper. So we're going to replace wrapper with something else. The most critical element to getting things working is the root element, since it's required to create the root fiber. So basically, you're not going to see anything rendering until at least you get your root element solved first, right? It's kind of the first problem to tackle. What I'm replacing wrapper with is something called file. And that is because if we go, let me get this away, okay. Let me just show you the AST Explorer. This is a really useful tool, by the way. But if I go look at AST of this code, it's got like file is like the very top thing. So in this case, file is kind of the most logical thing to be at the top because that's what the Babel AST is doing. That's why I called it file. If you're making a renderer for something else, you're probably not going to call it file. Does that answer your wrapper question? Yeah. So that's because we're using React the React reconciler, I don't have to do any of that. That's all under the hood, right? So if you look at this, here's the JSX where the JSX comes in, right? That's all those like brackets and all that, right? That comes in here, and I pass it to this update container. I did not make this. This is part of this reconciler, which is coming from, you know, my own little reconciler I made. But what did I make my reconciler from? I made it from React Reconciler, right? So that's the really nice thing. I don't have to tell it how to interpret JSX. Okay, so let's see. Okay, so right, so I replace wrapper with file. What's it doing? The node, right, because this first parameter that I pass into super, basically the first parameter I pass into base element is my node, right? My base node. So before I was putting JavaScript objects, now here I'm putting basically essentially what you see up here. If I was to have this page empty, it's basically this. I'm just using the Babel types API for it. Okay, so that kind of initializes everything. And then of course, inside of render, I have to just update this. My root element is now going to be file, not wrapper. Also, I forgot to say something about phase C. That's kind of important. So phase C is when I started creating these custom elements, or maybe it was phase A, phase B, sorry, was it phase B? Yes, sorry, that was in phase B, where I made these custom elements. When you first start making the custom elements, one thing that you also need to make is a factory function to create elements. Okay, so all this does is it takes an element type, which an element type is the string of, an element type is the string of your JSX component. So if it was hello, this is going to be the string, all caps, hello. And so you use this element type to pick which element you're trying to render. And this create element gets called inside of your reconciler. I did mention this, right? We have to create our phase C. In phase C, I did two things in phase C. One was append child, and the other one was create instance, right? I created the initial instance. I'm just using this factory function that I made, where it passes in the type and the props. Where does it get type and props from? From this lifecycle function. And where does that come from? Again, that's all under the covers of the React reconciler. I don't have to really know how it's getting it or how it's working. It's just giving me the type, and I'm picking in this create element function the specific elements that we want. Okay. Okay, I think, oh, I didn't test phase D. So what were we doing in phase D? Creating the node, replacing the element. Okay, so yeah, so if I render phase D, we should see the root node rendered, just like we did before in the other phases. But this root node should now be AST. It should not be just an object. So I run this, and here we go. Here's the rendered output. This is basically type, program, comments, tokens. It's kind of this. I actually would have to change some settings here to make it be exactly Babel's AST, but that's basically this is Babel AST code, or a Babel AST object. Okay, so now that we've set up our node, let's see. Yeah, okay, let's move on to phase E. So phase E, we bind our base element lifecycle methods. So this is kind of similar to what I did in phase C, where we created the append child so that we could append children into the root node. But instead of making it only work with the root node, I'm going to put these lifecycle methods in a more logical place, the base element, because the base, everything is extended from base, is inheriting from base element. So all of our future elements that we make, we won't have to recreate these functions unless it has a nuanced difference. But for the most part, like 80% or even 100%, depending on what you're building, like you don't need to redefine or overload any of these methods. Okay, so yeah, so that's why you'll see in phase E, you won't see inside a file any sort of lifecycle methods because they're all inside a base element. So what did I do here? We have append child. So this is just saying, here's what we're going to do with the AST node when we append a child. Okay, and I'm not going to explain the nuanced details about Babel AST, but basically, like, this is what, whenever we get append a child, this is what we do. And remove child, right? Here's all the code of how to remove a node from the Babel AST when the remove child event gets triggered, which is probably unnecessary for this renderer because it's a direct renderer. It probably never will be removing children. But if I was doing a side effect renderer, you would definitely need this. And then commit update. So these are the three most important methods: append child, remove child, and commit update. Commit update is really pretty simple. I'm just taking the new props and merging it with the old props. And commit mount, so you don't need all of this stuff done, on phase E. But this is basically non-critical. It's important for certain things, but it's non-critical for my demonstration. So, and I filled those out, but then I also need to attach the reconciler to them. And I have here in this README file, basically the critical methods in the React reconciler that need to be filled out. So append child, remove child, and commit update. Okay, so inside of the reconciler, append child, here we go. Oh, I guess I do that in the next step. Okay. Well, append child was already done in like step C, I think. So we already have append child in our base element will get called whenever it needs to append a child. So let's look at the example. We have, I'm kind of going backwards because, I'm not doing these hello and howdy elements anymore. But so for this step, for phase E, it's probably going to look the same as phase D because I'm not really doing anything yet. But we do have those element lifecycle methods filled out. So now in phase F, we can start phase F. We can start attaching them. So bind critical element lifecycle methods to the reconciler lifecycle methods. And so, yeah, so here's the critical ones that basically need to be filled out. So the React reconciler has these specific methods that need to be filled out. So create instance, this was already done in phase C, so we don't need to do this one. Append child, and basically we just take the parent instance and call append child on it, and we pass in the child that the React reconciler gives us. Append child to container, it looks the same as append child, right? We're just calling append child. Append initial child, same thing. We take the parent instance and the child, and we pass the child into the append child method. Append child is basically the most critical one. If you can append children, you can, especially for a React renderer that's a direct renderer and has no side effects, you can pretty much start rendering things, start composing stuff together. Okay, so let's see. Do I compose anything in the example? Nope. So this example for phase F is also probably going to look the same as phase E because we don't really have any file. File is the only element we've made. So we can't really render anything other than file right now. So, okay, so let's go to phase G. If I put file inside of file, it would probably put this object inside of this body. because that's how I told it to append children, right? So if we look inside a face element, I'm saying when we append a child, if we're an array, then we just push it into the body. And then set body, this is a more complex thing. This is very specific to my renderer, but basically, so I can pass in string paths. But yeah, I don't want to confuse you guys. But yeah, I should probably put it inside the node. So let's do it. Let's do it. So theoretically, if it works the way it should. So let's put inside of this, let's import from here. Let's import file and render it. File. It's gonna work. Yeah, I did that. Exactly what I thought. Because that's how that's what I told it to do when you append children to it. So basically, it's gonna do the same thing with other components, right? It's gonna put them inside of its body. Well, it looks like I didn't put it here, but put it here. Anyways, this won't render out proper code, but that's what I mean by React is very composable, right? You can do silly things like that. Okay, phase G. We don't have, phase G is where we start creating all our custom elements. Then we can actually start doing some useful stuff. So we create our element constants, very similar to what we did in like phase C, I think, phase B or C, right? So here's our constants. So I'm creating all of these elements, one called smart, one called program, we'd already made file, one called expression, one called AST. The names of these are very specific to, the reason I'm naming these the way that I am is so it kind of matches, so it has good, so it matches the Babel API. So all of these things are specific node types that Babel provides. And then I create my intrinsic element types because I'm doing TypeScript. So here's all of this. And you'll notice file can have children. Smart can have a bunch of things, including children. Actually, if you look at smart, the way smart works is you basically give it a string of code and what children, and then it basically shoves that code, shoves the children into the body of the code. So for example, let me just show you a real quick example of this. It's pretty cool. So I can say, so this is a worse example. Here I'd say smart, and then I give it some code, and it should give me the AST of that code. So let's go to phase G. Right, so here we have this bigger AST tree, and we have a variable declarator called hello, and it's got the value world. All right, so looks good. But the reason it's called smart is because it's pretty smart. Actually, the word smart actually comes from the Babel AST. It's not something I made up. But I can create a function called hello and give it an empty body, and then inside of it, smart. I can give it another smart. Theoretically, this should work. And say const hello equals world. And it should put this inside of this one's body. Okay, let's see if it works. So we have our variable, okay, we have our function declaration. And inside of the body of our function declaration, we have a block statement. And inside of that, we have our variable declaration. So it put it inside of there. And if I was to render this out into code, which we'll get into a little bit later, you would see that it actually put, yeah, I'll do that later. But you'll see that it actually put this inside of the body of this, basically. Okay, so I'm done with phase G. So phase H, create text bindings. So how do you do things with text? Like, sure, I made an example. Like this. What if we just put this straight in there as text? How is it going to handle that? So the way that the React renderer works is it has these special reconciler methods for text. Let me go into the README file. It has special reconciler methods for text, and you explicitly tell it what element you're creating. So create text instance. This is going to create a text instance. And here, basically what I do is I create a smart element, and then that code prop, I just pass in the text. So it's just going to, and I have to do this commit mount thing, but this is kind of, this some more nuanced specific things to my renderer. But basically what my text is doing is it's just creating a smart and then just putting this inside this code. That's what it's doing under the covers. There's a few other text lifecycle methods you need to create besides just create text instance. Reset text content. This one, I just did a no op inside of it. This is not necessary for my renderer. Commit text update. I think that's also not necessary. Yeah, I even, in this one, I throw an error, basically. If this one's getting triggered, like something's wrong, because it really shouldn't be updating, because once it's done rendering, you're done. Should set text content. This one is important. This is how it knows if it's a text component. So basically, if the child prop is a string, then it's text. Oh, it's not. This is actually very copy-paste. Like pretty much every React renderer would have this function look exactly like that. Okay. So theoretically, this should run, and we should end up with this and this in our AST. So I'm in phase F. So it's going to be hello world and howdy Texas. Okay, I think something's not right. Oh, I'm on phase H. I went backwards. H. Okay. Okay, so here we go. Const hello world. Const howdy Texas. So it worked. It's doing, it now supports text components. Okay, let's move on to phase I. Okay, finish our reconciler bindings. So there's some reconciler bindings that are important, but not critically important, okay? And so here I'm just gonna go through and finish them. So get public instance, I just pass through the instance. Some of these I actually just copied from Facebook. So, but most of these are non-critical. This one I just left it as a note. Prepare update, I just have this return true. Reset after commit, no op. Finalize initial children, I return true. Commit update, I run the commit update function on that element. It's called instance, but it's an element. Commit mount, I call the commit mount function on the element. And should prioritize subtree, I'm just returning true. Schedule deferred callback. If callback, I throw an error. Again, I kind of copy pasted some of this, so I don't have deep explanations for all of it. This one is a no op, cancel deferred callback. But these I can explain. These are definitely important. So set timeout. React actually, the set timeout in React is actually not the native set timeout function. So you have to tell it, when I call set timeout, what are you calling? If this was the DOM renderer, this would probably be window.setTimeout. But since I'm using Node, this is just set timeout. Same with clear timeout. So basically, yeah, basically I just filled out the rest of the methods inside of this function. Okay, so let's look at the example. It's probably the same as the previous one. Yeah, let's see if it actually works. Phase I. And it's completely identical to the previous one. But now it supports things like set timeout, which is important. Although probably not important for a code generator, but still. Okay, J, phase J. Add default props. So one thing I found out is that you have to create the logic for handling default props and validating prop types manually. It doesn't do that out of the box. So I put all this logic inside of the base element. And if you look at the previous way I was doing props in my base elements, I was just, whenever props comes into the constructor, where's my constructor? Whenever props comes into it, I just set it to this dot props. But it's not doing any default props. What if there's default props and props is an empty object, right? Then it's not gonna set my props. So that's a problem. So basically now I have props, this dot props equal to this dot get props. And then here I just do a bunch of stuff where like, you know, if the prop doesn't exist, but there's a default prop, put the default prop, and then validate it all to make sure that the prop types match, and then return it. And this one, I do have an example of it working. I have, yes, where do I do this? Sorry, I'm on phase J. That's why the example didn't look right. Okay, so if I look at the example here, it looks a little bit more complex. I made a component called app, and I gave it some default props. Hello is set to const hello equals Austin. Howdy is set to const howdy equals a function callback that says Austin. And so, but then when I render it out down here, I set the hello prop to hello equals world. So theoretically, if my prop logic works correctly, this hello should equal world, not Austin, the default prop, and this one should be Austin. So let's try it. Okay, so hello, const hello world, that's directly overriding the default prop, but this one, const howdy Austin, is getting it from the default prop. And if I hadn't put that prop logic in, this would have been basically empty because it wouldn't know where to get that default prop from. Okay, so that's it with phase J. So moving on to phase K, we're getting really close to completing our React renderer. So add options. So this is not technically required, but a lot of times your renderer is going to need some custom options that tells it how to operate on certain conditions. So let's see my example. Okay, my example, I'm not really testing it, but basically options that I have to provide for this, because it's supporting things like TypeScript and JSX, the Babel, you have to enable or disable certain plugins depending on what type of code you're working with. So if I'm using TypeScript, actually I have a good example of this in this last one. If I'm using TypeScript, when I do my render, I have these options I have to create. I have to enable these specific plugins. And here I even added an option for prettiering the code at the end. So that's what I mean by add custom options. So for adding custom options, I kind of did a bunch of stuff here. Some of it's very specific to this renderer. Yeah, so if you look in the render function, it's now a lot bigger than it was before. My render function is no longer doing the regular render stuff. That's my render AST function. This is basically what my previous render function was. You know, update. And I have this update context where I pass some options into this. This is specific to my renderer, so I can access that data from other places. This all looks the same as before. But the reason I renamed this function is because the render function now does the render AST, and then it takes that AST and turns it into code, and then it prettiers it if you enable prettier. So it's just doing a bunch of extra stuff. I have a util in here. No, I made that util earlier. Anyways, this is really specific to the way that my renderer works. But, oh yeah, one other thing I added in here that is useful is in the, here I added support for DevTools. And here I'm basically just checking, are we in a development environment, which is what this is doing, if this dev environment variable is set. Okay, so, yeah, okay. And I had to for the options, sorry, one other thing. In the options, you need to set the types, right? So I replace this with my specific types, right? All the different options that you have available. Okay, so this is K. So when I render out K, it's gonna look the same. No, it's gonna look different. When I render K, it's now gonna actually turn it into code. This will be cool. Yeah, const hello equals world, const howdy equals Texas. Okay, so if we look at the example that we gave it, here we go, const hello equals world, howdy equals Texas. So that's working. Okay, let's move on to phase L, which is our last phase. So here we create our components. So up till now, all we've been doing is making elements, which if you look at elements, let's look at base elements. It doesn't look, it's pretty gross. Like the code in it's not very straightforward. We have these very specific render lifecycle methods we have to call. You really have to know how React Renderer works and what you're doing to build these elements. Smart, for example, is doing some very specific stuff that's probably going to be different depending on the renderer you're making. So what's better is to do as much stuff in regular React components instead of doing everything in elements. Now, regular React components are built on top of elements, so you still have to make your elements, but it's good, at least I found the best approach is to make really broad general elements. That way you can do most of your logic inside of components. And if you look at this, phase L is basically the current version of React AST. If you look at this, most of the code in React AST is actually just regular React components. Like this is just looks like a normal React component. It's got a render function, and it's calling into these elements. It's calling into Smart. I'm using Smart all over the place. Almost every single one of these uses Smart. So the smart way to do it is to have very broad elements and then use them in your components. Okay, so yeah, here I basically say the same thing. Okay, well, let me render out. Okay, let me render out my example, and I made some really nice examples here to really show you how using something like React, you get access to these nice features like composability. So here I have a body, and I create a JSX element called hello, and I give it props called body props. So basically what this is gonna do, this is a React component that's built on top of my Smart element. What this is gonna do is it's gonna generate something like this. It's gonna generate some code that looks very similar to hello, and inside of hello, it's gonna put in this object that says hello world. That's exactly the code that this component is going to render. I'm using JSX to render JSX, exactly. And you'll see here that I'm using React to render React components when I go show you these. So, so here I have, this one is a lot more complicated, but nonetheless, it's still pretty readable. Compared to something like my TSGIR, where I'm literally just directly manipulating Babel. This is very unreadable. This is the alternative, and this is, you know, it's not like writing code itself, but it's still pretty readable. Okay, I'm importing React, it's exporting component. And then I do a default export, and I'm exporting my class declaration. And the name of my class is going to be whatever the name prop is that gets passed into it, and it's going to extend component. And it's going to have a class method called render, and render is going to return whatever child I pass into this component. So you can see here how composable this is going to be. And then here I have a functional way of making a React component. Looks pretty similar to the other one, except for it's more the functional way, importing component and FC. I guess I don't need to import component. This is a functional component. I don't need that. Anyways, I'm importing these. Importing, why is this called exports? I'm a little confused. It's called yeah, these are the exports of what I'm importing. It's the way that the Babel AST called it. So I kept it the same. Anyways, it's just saying import React component FC, React node. Anyways, okay, so I don't need this one though. Okay, then I make an interface declaration because I'm doing TypeScript here. And so here I make an interface declaration with method signatures, and then with this prop, and then a variable declaration, and I create a little fat arrow function, and the return statement is going to be props.children. So then inside of here, I can import body, React class component, and React functional component, and here I can render React functional component using body, and up here I can render React class component with the same body. So it's very composable. I'm generating code in a composable way, which is very, very hard to do, right? If you're using templates to generate your code, it would not be composable. You know, you could think, oh, well, you just copy paste the code into it. That only goes so far. Like what happens when you're passing around generics and you know, you have functions defined that you're then having as the data type of other parameters. It does not work with the templating engine. Okay, so phase L. So I go to phase L. And you can see here, it rendered, by the way, look at all of these lifecycle methods that we log. Quite a lot. It's really cool. You can see every single little thing that the React renderer is doing. But anyways, you come down here and you can see, here's the body that I passed into my functional component hello. This is what it's going to return. And you can see up in here is the class version of it. So probably using React AST, you could really easily make a library, if anyone wants to do this. If no one does, maybe I will someday. But you could really easily make a library that converts functional components into class components, or converts class components into functional components. It's pretty powerful. Okay, that is, yeah, that's it. That's React AST. Okay, so let me go back to my slides. Okay, yeah, here's all the phases that we did. Okay, so yeah, just some tips. Abstraction is your friend. Build your renderer in many layers of abstraction. So this renderer has lots of layers of abstraction. We have our React reconciler, and on top of that, we have elements. And on top of elements, we have components, and on top of components, we have other components and other components. So you really want to, abstraction is your friend. As I said before, create a few elements, create lots of components. Elements are hard to build and hard to debug. It's best to have a few broad and general elements and then build lots of specific components on top of the broad elements. Start small, increment in small steps, as I basically demonstrated. Use TypeScript. This can catch lots of unnecessary bugs. TypeScript is head protection. Because before I was using TypeScript, I was banging my head on walls for silly bugs I wrote. Right, unit tests, and mine, I unit tested every single, and I didn't unit test my elements, I probably should, but I unit tested every single one of my components. And they're actually, for this renderer, they're actually pretty, most of them, they're pretty easy to write, right? Like render this, expect this to render this code, pretty easy. Yeah, build a solid foundation. Right? If you have a solid foundation, then then it becomes it's much easier to build React components on top of your solid foundation. So, okay, I didn't put this in my slides, but also I'll go over this real quick. So debugging, here's a debugging tip. So you can get access to the node data from a ref. In fact, you can actually test this in, you can test this with React DOM. React DOM is pretty easy to test this. right? If you want to get access to the actual real DOM, you can do it through a ref. So for example, the following will log the data from the node used in the smart element. This is very helpful because the ref runs before the entire render cycle is finished. So this is really helpful for debugging bugs that are preventing the rendering from finishing. I found this super helpful. There are some bugs that I would not have been able to find because it would just blow up my render, and then how can I know what the output's gonna be? So you just attach a ref, and then console log the node. But this only works on element refs. It's not gonna work on regular React components because elements are abstractions of your nodes. You can see the value of the nodes. You cannot see values of the nodes in component refs, right? We very explicitly put nodes inside of our elements, but components don't have nodes. So this example here, where I make a little function declaration, this would log undefined. So if you have to debug a component using a ref, it probably means your element is flawed somewhere. And yeah, you'll just have to debug your elements. Anyways, yeah, that's it. That's it with my presentation. So I'm gonna open the floor up to Q&A. Okay, yeah, give a little time. Yeah. Is this a step towards doing that? It is. So I'm gonna, yeah, future projects. I'm going to rewrite my TSGIR using React AST because, like, I literally hit a wall. And the wall I hit with this is, I mean, this did generate all of these bindings, 40,000 lines of code. And most of it worked. Like 95% of it worked, and the little bit that didn't work, I wrote a little script that put @ts_ignores on everywhere where it didn't work. Actually, that's another project called ts-ignore. But anyways, don't use it. It works, but it's, yeah, it's bad. Anyways, where I hit a wall with this is I had functions, type definitions of all my functions. But then what if I'm passing functions in as parameters into other functions and it needs the type data attached to it and passing type data through generics? Like basically, like this was just becoming super unmaintainable. I mean, it's like almost 1,000 lines of code. But I feel like with this 1,000 lines of code, I can split up into lots of little React components that, you know, make it very composable and should theoretically be able to pass in all that type information and those generics around. Yeah, then I'll regenerate all of these dependencies. Then I'll make basically another renderer like TSGIR, but instead of generating TypeScript bindings, it will generate all of the, so you can see here, I mean, this is a React renderer too, just like the other one I was showing you. Instead of generating TypeScript bindings, it's gonna make elements for all of these things. It'll basically generate this code, right? So this, I mean, this is another element, kind of like I was showing you with my, you know, like the smart element, but this one's specific to, you know, GTK. It's, let's see if you look, yeah, the node here is an actual, like a GTK box. Anyways, but yeah, I'll actually be generating this. So I won't be using React just to generate React components. I'll be using a React renderer to generate another React renderer, basically. Yeah. Yeah, any other questions?
If you have like a class method component, does it complain if you don't put it inside class method?
If you have a class method,
there are rules around.
Right, there's some rules around code, and actually, anything that complains that says you can't do this is going to happen at Babel's going to complain. So if Babel can do it, this can do it. And yes, Babel can render some really funky code. You can I'm trying to think of something really weird you can do. You can do some really weird stuff with Babel. Like, I mean, I just showed you earlier putting a file inside of a file. Like, you know, what's that supposed to mean, right? Like, that's pretty weird. You could put a a class method outside of a class, right? That's not going to work. But like Babel actually does let you do it. So anything that Babel lets you do it's gonna let you do. If you're actually using React AST to render code, probably you should have a post-process step that actually type checks it and like test it and make sure it's actually valid code. But yeah.
Would you implement some of those checks to be inside the fn child or class?
No, I would not put that logic inside of the React renderer. I'd put that like as a whole separate post-processing step. Yeah. You want as little complexity inside of those elements as possible, right? You do not want to be like putting code you're going to have to maintain in those elements other than like the bare minimum of what's required. Yeah. Okay, so yes, anything that works with React, which is really cool. So you see these, this is pretty cool actually. Because it's built on top of the React reconciler, basically all React features that React version of the reconciler supports is going to be supported. For example, yeah, so yeah, let me, so for example, you have inside of your reconciler, even though the lifecycle methods are not identical to the React component lifecycle methods, they're related. And it's helpful as you're building this out to think of component did mount, component did update, right? But you build it that way and you think of it in terms of those lifecycle methods, but then is it going to support hooks and functional components and all of that stuff? Even though I wasn't thinking about it as I was building this, yeah, it will, because the reconciler is going to support that stuff, which is actually a development tip. Like if you're developing this, don't think of this necessarily in hooks. Think of it in terms of just their traditional React lifecycle methods, but it will support all of that. Yeah. Does that answer your question? Yeah, I didn't, like reconciler did it for me. Yeah. Yeah, things like this.state and stuff like that, yeah, that's all handled by the reconciler. Yeah, I mean, you can think of the reconciler, like, how did I define it here? I defined the reconciler as, I mean, it's not an official definition, but it works. I defined it as the bindings to the React reconciliation lifecycle methods. So you're just talking to the React reconciler API. You're not actually solving the reconciliation itself.